a block, we can treat it. I'm going to release. So somewhere at any arbitrary position, what are the conditions? We'll check it. So here, this is the M. So let this angle, anything you can write it as. So this is theta, or this is theta, you write it. Or we'll take it, this is theta. Then how the friction force? The friction force will be acting in this direction. If this is theta, theta will be 0 to 45 degrees, no doubt. Mg sin theta or mg cos theta will come. I'll define this theta. It'll be easy for us. So this will become theta. So here mg, so mg sin theta will come into picture. This is a normal contact. So on this side, it will be mg cos theta. So what it's telling is like, will the eraser reach the lowest point of the track? So it will slide like this. From rest to rest, it will move and it will slide down slowly. Let's assume that one. Then what is the work done by friction? So work done by the friction should be equal to F into ds. ds is the arc length, or this will be mu n. ds will be r d theta. What is d theta? D theta, we can define it like this. So that will be ds. I'm unable to show ds. So this will be mu mg cos theta r d theta. So mu mg r cos theta d theta. Okay, this will be now theta. So mu mg r cos theta d theta. So what should be the limit? No, theta should be, I think, so shall we take it 0 to pi by 4? Or initially it was pi by 4, finally it will become 0. It does negative work, no? Okay, we'll put it. I think all symbols are missing. Okay, this will be negative sign. Sin theta. So mu mgr by root 2. Okay, this is a work done by friction. How much a decrease in gravitational potential will? So that should be equal to mgr minus mgr cos 45. This is a work done or decrease in gravitational potential. Delta U, I'll write it. So what do you expect? This will be 0.7, 1 by 2 is 0.707 will write it, or 0.7 we can take it. So this will become 0.3 mu mg. 1 by root 2 will be 0.70 or 0.7. Mu is 0.6, no? Okay, this will be 0.7 into 0.6 mgr. 0.42 mgr. This is work done by friction. If the really the block moves from, it will start from A to reach B. Then when it moves from A to B, delta UAB, I'll write it. This will be easier. How much it is? 0.3 mu mg, and mu is how much? 0.6. So this will be 0.18 mgr, which will be greater work done by friction. So therefore, the block cannot reach B. Okay, agree. So if the particle will never be able to go from A to B. Any reason what we can put it? WF is greater than WUAB. So the decrease in potential energy is less than the work done by friction. So therefore, the particle will never go from A to B. I think we have to cross verify things. What is the conclusion? So therefore, the particle cannot not be able to go from A to B. Therefore, will not be able to okay, this option C is what we have verified. Okay, let's take all the things one by one. Okay, just cross checking. Okay, there's a method of getting that idea of the friction. Next again, if the particle slides from A to B, work done by frictional force will be. I think okay, we have derived it. That's what the formula. Okay, this is the correct option. If it slides from A to B, no, the particle will never be able to go from A to B. This is correct. No, if the particle slides from A to B, work done by frictional force will be greater than. I think it should be. This is what equal, no? So check it now. This quantity is greater than this. I think no, pi is there here. He has brought pi also. I think should be less than, no. So this is not correct option. So this is correct option. I'll pick up. This is not correct. This is correct option. No, if mu is root 2, the particle will not begin to slide. How to justify this? I think at this particular thing, what is tan theta?
B is correct, na, sir.
Pi is there, no? 3.14
Yes,
by
sir.
4. How much you'll
Pi
get?
by 4 is less than 1. The work done by friction will be greater than that value.
Even 4 is there in denominator, sir.
4 is there. Huh? Okay, I didn't check. Yeah.
Sir, if it cannot go from A to B, then why we are talking about the work done by friction, sir?
If I will move, if I will slide slowly, if particle slides, if is telling.
Okay, sir.
There's a nice problem. Like already, I think once in weekend exam it came. This is mu. Huh? Okay, what to do with this last option? If mu is root 2, the particle will not begin to slide. I think you check here tan theta should be greater than mu, no? So at this particular point, tan 45, if mu is root 2, what will happen? It will not slide. I think it's correct statement. The particle will start its motion from here. So tan 45. So tan 45 is 1. What is mu? Mu is. So when the particle slide, only when tan theta greater than mu. So for option D, what we can put explanation? Tan theta is less than mu. So therefore, particle will not slide. Because I'll release at A. At A only